Walao eh, what should we do for our physics project leh?
I think we can make the generator lah.
Can we imply the electromagnetism concept?
Sure! Then how should we design our model?
Since I'm playing Pokemon Go right now, let's make a Pikachu lah. Oi, oi.
Meanwhile,
Hey, where is our physics model?
We put it at the SK3 205 ma.
Oh, SK3 205 huh? Okay, let's go and see.
Let's go. Hey,
Our product is over there.
over there.
Walao eh, you guys steal our product, is it?
Our
The model is already there before it came in.
You guys also made a generator ah?
Can you guys explain how did you make it?
Let us ask our expert to explain to you.
Oh, we got expert man.
I'm Dion, your expert from Pika Pika Institute. Let me explain the theory. So before I start my short briefing, let me have my two assistants to explain the definition of some of the key terms to you guys.
Do you know what is a magnet? Magnet is an object that produces a magnetic field which exerts attractive or repulsive forces on other magnets or magnetic materials. A magnet will have a north pole and south pole. A magnet itself will have magnetic field. Magnetic field is a region around a magnetic material or a moving electric charge within which the force of magnetism acts.
Our model, a generator, applies the concept of electromagnetism. Electromagnetism is a branch of physics that deals with the electromotive force that occurs between electrically charged particles. Our model, which involves the cutting of magnetic flux, will then produce electromotive force, which is also known as EMF. EMF is the electric potential produced by an electrochemical cell. At the same time, the cutting of magnetic flux will produce current, which implies the concept of electromagnetic induction. Electromagnetic induction is the creation of an electromagnetic force by way of a moving magnetic field around an electric conductor.
Okay, once again, my children, a very good morning, afternoon, good night, whatever you want to say, alright. My name is Dion Vun from Institute Pika Pika. Let me introduce to you this whole concept. Now, cameraman, can you please come over here? You want some sweets? Right, come over here, come over here. Okay, don't zoom in first, come, alright. Zoom out, alright. So you see this whole big structure over here, right? So basically this whole model is inspired by our Sarawak Bakun Dam. How it works is that the water will flow from a higher place, or basically we will fill water here first lah, okay? Fill here first, then the water will hit the spoon will go ta 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 ta. It will spin, and it will push the magnet over here. So if you can you zoom in, please? Thank you. So there's a magnet over here, which is encapsulated by a 3D printing cover. So once this turbine spin, the magnet will go in and out, and it will cut the. Come over here, please. There's a copper core over here, right? So when the magnet pass through this hole, it goes in and out. It will cut the magnetic flux and thus produce current. Now zoom out a little bit, alright? So once the current is produced, it will come to the transformer. Now some of you might be asking, why we use transformer? Okay, so this whole thing, right, it actually cannot produce a lot of electricity. So we need transformer to step up the electric, and also, once the electric is stepped up, please be reminded that this whole thing, the current is actually in alternating current. So we need a rectifier over here. With this rectifier, the alternating current will be transformed to direct current. Once we have direct current, the light bulb in front here, which you can see from the video just now, over here, it will light up. Alright, that's it for the whole introduction of the video, of the model. Yep. Alright, here are some additional notes for you. So some of you might be wondering, what are the uses of spoon? Alright, so if you zoom closer here, you can see there's a lot of spoon connecting to the turbine. So basically what the spoon does is that when the water flows down from a higher ground to the spoon will catch the water and hence rotate the whole turbine. Alright? Now, what are the uses of bearing? So, if you look closely into our model, there's actually a bearing placed in between the hole of the turbine here. Basically, what the turbine does is that it enables the turbine to spin more smoothly. Now, let's move on to the next point. Basically, if the turbine could spin faster, the induced current produced will increase. Alright, now some of you might be wondering, what is the function of a rotor? Now, basically a rotor is something that converts energy from one form to another. So in this case here, we have our turbine, which converts mechanical energy into electrical energy. Now some of you might be wondering, how to increase the magnitude of the induced current produced? Well, first of all, we can increase the power of magnet. If the power of the magnet is increased, the induced current produced will also increase. Secondly, we could also increase the number of coils of the solenoid here. Cameraman, can you please zoom in? Alright, over here. So if the number of coils of turns is increased, the induced current produced will also increase. Now, we can also increase the induced current produced by increasing the diameter of the coil. Thus, it allows more current to flow through it. For example, if you have a bigger length on the rod, definitely you will have more cars flowing through it, right? So this is a perfect analogy for this. Now move on. One quick tip is that if the surrounding temperature is too high, or whatever things that cause the resistance, whatever things that cause the copper wire to increase in temperature, the resistance of it will also increase. They are both directly proportional to their relationship. Hey, you think that's it, is it? No, we still have, that's not it. We still have another mini model over here. Well, let me call my two Pokemon assistants to demonstrate this whole concept. Alright, now in 3, 2, 1, you guys press it, okay? Okay, 3, 2, 1.
Hey, my grandma can do faster than you.
Oh no, alright. Since this is broken, I'll just explain the concept of this thing first. Cameraman, can you please come over here, please? Alright, so basically how this whole thing works is that it applies the same concept of this water dam over here. Just that instead of using the water to spin the wheel, to push the magnets in and out, we use our own manually powered hand to push the magnets in and out. I mean, up and down. So we do have a spring over here. Basically how it works is that once you push, the springs will be compressed. Yeah, will be compressed. And then once you release, the spring will push it back up. So the movement of the magnets up and down will cut the iron core over here, which applies the same concept as the water dam just now, and hence it will generate electricity. Wait. It's not iron wire, guys. It's copper wire. So now I have a question to ask. What if it is used? What if iron wire is used? Definitely, if we use iron wire, the resistance will increase because the resistivity of iron itself is much higher compared to copper. So if the resistivity is increased, the resistance of the whole wire will increase. Thus, the induced current that flows through it will be reduced and the light bulb will be dimmer. Alright, so let me perform my magic first, and once everything is fixed, I'll demonstrate again. This is future Dion here. Actually, we don't have to fix it, because if this thing is broken but the wire is still attached to this whole thing, the current could still flow effortlessly through this whole product and light up our light bulb. So, what a dummy.
So now I will explain the calculation part for the magnetic flux. I will use this formula. And magnetic flux is the amount of magnetic field enclosed by an arrow. This is the amount of magnetic field, and then this is the cross-sectional arrow. And we use this formula. Magnetic flux equals to B times A times cos theta. B is the amount of magnetic field, A is the cross-sectional arrow, and then the theta is the angle between the normal of the coil to the magnetic field. For the water turbine, we are using this formula. So 1.4 is the magnetic field of neodymium magnet, and the A is the cross-sectional area of the copper wire, and then the angle will be 0. So we get the value of 2.75 times 10 to the negative 3 revolt. And then for the interactive part, also we use the same value of the magnetic field, and then this is the cross-sectional area of the copper wire, and then also the angle will be 0. Then we get the value of 8.62 times 10 to the power of negative 4 revolt.
Okay, good morning, good afternoon. Now we move to the Faraday's law. This is the formula for it. This one, the reverse 3 is the EMF produced, electromotive force produced. And then this negative is just the direction, not that important. This is the number of turn of coil, the N. And then this is the change in magnetic flux, which is the result, the value that you calculate just now. And this is the change each time. You can calculate using a stopwatch. Okay, for the water turbine, this is the calculation. We just subs in the number of turn, and then the answer just now, and 0.5, which is the change in time. Use the stopwatch to count how long does it take to produce the electricity. So sub in calculator, the answer here. Okay. Now move to the interactive part. It's also the same same formula, just different value. Subs in the H value, then boom, answer. Easy, right?
Okay, let's move on to the inductance. Do you ever wonder how do we get this equation? It's derived from the Faraday's law. Faraday's law is equals to this equation too. And we will substitute the equation of change in magnetic flux into here. So we will get this equation. And why it is 0 degree? It's the same reason as we have explained in the magnetic flux equation previously. And then after this, we will substitute the change in magnetic field equation into this equation, and we will get this equation. Yeah. And now we will do some simplifications and cut, move, and we will get this equation. That's all.
So we use the formula just now we get, and to find this one, we sum the number of turns of our copper wire, and this permeability of free space constant, and this is our area of our coil and our length, and we'll get this 2.75 multiplied 10 and the power of negative 3 Henry. And in this one iterative part for the small one, we also submit the information and we'll get this.
now we'll proceed with the calculation.
Shoot. My turn. Ni mau nghe. So now let me introduce the formula. So this formula is for our transformer for the water turbine. So this one is the voltage primary one, and this one is the voltage secondary one. So this is our input voltage, and this one is our output voltage. So this one is set up ratio, and we need to find our output voltage. So our output voltage is 2.3 voltage. So now move on is our interactive part. We use the same concept with the water turbine. So only one difference is this one, because we use the set out ration is different with the transformer. We use different transformer lah. So we will get this answer.
Alright, that's all for our presentation of the product today. Before we end, let us have a photo session with all my kiddos. I'll summon them first, alright? Hiya! Hey!
Wait lah, my leg hurts leh.
3, 2, 1, behind!